Next, we move to FM average power. So to get the total average power for FM, we can use this equation. So the power total is equal power of the carrier times the component for the carrier J naught squared plus 2 times the summation of the other sideband pairs from n equal 1 until n. So FM RMS power is dissipated in a load R, so we can get V RMS over 2, and then we substitute in V squared over R, and so we get VC squared over 2R. So we substitute this as in RMS value. So VC squared over 2. Sorry, there should be set 2. So if Jn is too small and J naught is equal 1, so the power total is equal power of the carrier. So when we total this, so total is too small, so we just consider power total is equal power for the carrier. So when modulation is applied, power in carrier is distributed between all sideband components. So it is different with DAM, where most of the power is located at the carrier component compared to FM. So all power is distributed between all the sidebands. So I want you to try this question. Now we can classify the FM as wideband and narrowband FM. So the bandwidth of an FM signal is depend on the frequency deviation delta F. So from the equation, so we know that the delta F is actually equal KF times VM, where the deviation is controlled by KF VM. If KF is too small, so the narrow bandwidth will be produced, while if KF is large, so we produce wide band FM, WB FM. So what is narrowband and wideband FM? So basically, narrowband FM or NBFM has modulation index less than 4. So the modulation index is less and equal 4. The frequency deviation is actually between, so frequency deviation is between 5 kHz to 10 kHz. The bandwidth for narrowband FM is from 10 to 30 kHz. The maximum modulating frequency is 3 kHz, and the application for the narrowband FM, it is used in public service communication such as taxi cab, police, ambulance, or ship-to-shore services. Basically, this kind of service, the voice that they are sent through the user is not very clear. So you just compare to the radio station, you can listen to this example. Walkie-talkie that use narrowband FM. Okay, so hopefully you can understand what is narrowband FM. Now we move to wideband FM. So basically the modulation index for wideband FM is greater than 4. So the maximum frequency deviation is 75 kilohertz. The bandwidth is approximately 15 times higher than the narrowband FM. Modulating frequency range is between 30 Hz to 15 kilohertz. And the application that choose wideband FM basically in broadcasting, where it is used in television broadcasting. So they're not the higher quality of the voice, so they choose the wideband FM. Now we move to FM transmitter and receiver block diagram. So basically for FM transmitter, it is generated in radio station or regional broadcasts tower. So for FM transmitter, the modulation signal is transferred to the audio amplifier and then enter the FM modulator. So FM modulator, they will add the carrier signal. So in this block diagram, the carrier frequency that basically generated is around 88 MHz until 108 MHz. This is basically for Malaysia. So it has been used in Malaysia. So kalau you tune your radio saja dekat rumah atau dalam kereta, so you akan see that the frequency of your radio, dia akan start from 88 MHz until 108 MHz paling maksimum, and then dia akan patah balik to 88 MHz. So this has been set up by the regulatory body SKMM or MCMC. So they has decided to choose this frequency. So basically this frequency is varied according to the country. For Japan, they have choose the lower carrier frequency, I think around 70 to 90 megahertz. So try to avoid buying Japanese radio manufactured for Japan market, because you only can listen to the radio at the lower frequency, and sometimes the kereta import yang come to Malaysia from Japan, so they already have embedded the radio dalam sistem dalam kereta tu, and you can only listen to the frequency from Japan. So you must be careful when you buy electronic gadget or appliance. So in modulator circuit, the carrier frequency is modulated by the modulating signal which produce FM signal. So the FM signal has a bandwidth of 200 kilohertz, including the guard band 50 kilohertz, to prevent interference from adjacent channel. So it is then amplified by the RF amplifier before it is transmitted and broadcasted through transmitting area to the listener. Okay, this is the FM receiver where you receive the FM signal. Basically, it is in your radio dekat rumah atau dalam kereta. So basically this kind of circuit yang ada dalam your own radio. When the receiving antenna they receive the signal, so it will amplify using RF amplifier and then mixing with the local oscillator. So local oscillator basically they will choose the intermediate frequency signal. So basically you need to tune your signal. So radio kita boleh tune to get the siaran kan. So this is how you tune to FM radio station. When you tune the signal, you actually change the intermediate frequency. So what frequency you are want to listen, so such as maybe 97.6 megahertz. So you tune to 97.6 megahertz. Amplitude variation in the received signal caused by noise can be removed by simply limiting or clipping in the limiter circuit after the IF. So we amplify and filter the signal. So we limit or clip the signal to remove the noise before it demodulate in the demodulator. So the signal to noise ratio is actually have been improved a lot in FM compared to the AM system. So sebab apa kita in commercial kita still listen to FM because the quality of the signal tu adalah sangat-sangat tinggi berbanding dengan AM signal. So, what are the advantages of FM compared to AM radio? So, first is the noise immunity. So, FM is actually operated at higher frequency than AM. The higher the frequency, the immune is very high to noise. That's why in 5 gigahertz or 5G technology, they choose to use around 20 to 26 gigahertz of frequency because it want to transmit more data when it is higher the frequency, so it can carry more data, and at the same times it is higher immunity to noise. So next, the advantages of FM is to improve signal to noise ratio SNR, where the FM limiters can reduce the noise level and improve the SNR. FM SNR is increased about 25 dB higher than in AM. So SNR is where we transmit the signal. So we have the signal level and we have the noise level. So this level we call as signal over noise. So higher the gap between the signal and noise, so it will be produce a better quality or performance of the signal. So next is power utilization and efficiency. So with FM, all the transmitted power is useful because power is redistributed in the sidebands. So compared to AM, so most of the power is only transmitted in carrier. That is actually contains no information at all. But for FM, it is redistributed in the sidebands. So next FM use low transmission power. So the FM modulation process can take place at low level power stage in the transmitter, so it will produce a low modulating power. And lastly, the FM signal has guard band. So the guard band is allocated by the standardization body such as FCC or SKMM. So basically FCC, they have decided the special guard band to prevent the interference from the adjacent channel. So there is no guard band in AM spectrum. So to avoid the interference between one radio station to another radio station, so they put rules that for each radio station guard band 50 kHz. Dia macam bagi gap kat situ supaya to avoid the interference. So disadvantages of FM, so it use wider bandwidth. So actually FM produce many side frequency compared to AM transmission. So as you can see in Bessel function table, for modulation index 10, so it will produce 14 pairs of side frequency. So in FM, the bandwidth is 200 kHz, and for AM it's only 10 kHz. For FM, the circuit is very complex and higher cost to be implemented. So in the early stage, FM stations are more complex and costly compared to the AM radio station. But however, with the latest technology, so they will produce a lot of new components such as IC. So the cost to manufacture FM signal is reduced. And then FM station has smaller coverage area compared to AM. So basically, the FM wave propagate in by line of sight. So line of sight, let's say this is the base station. So line of sight is like this, line of sight. So most of the signal is covered by the line of sight. So but AM signal can be propagated by skywave or ground wave propagation, which cover a larger area. But for AM, so they transmit and then it will reflect through the skywave or ground wave. So that's why AM can cover a larger area compared to FM. So that's why if you travel, let's say from Penang to Kuala Lumpur, and then you are listening to a radio station, so when you enter the typing area, so you need to change your frequency, and then you enter the Ipoh and then another location, so you need to keep change your frequency because of the FM that has smaller coverage. Next, we move to phase modulation. So phase modulation is another form of angle modulation, but it is only involved with phase. So basically it is almost the same with the frequency modulation. So the general expression for phase modulation, so we have this expression, and it is almost similar with FM. The difference here is we have MP. MP is the phase modulation index. It is equal KVM and equal to the phase deviation. this is the output for the modulated signal, and we have the carrier signal and modulating signal. So for PM, we choose the square modulating signal. So this is square modulating signal. So we have the positive and negative part. So this is basically digital. So only digital signals. Example macam ni lah, square. And modulates with the carrier. So you akan nampak from positive to the negative part. So the carrier, bila dia jumpa negatif, so dia akan ubah the phase 180 degree. Change the output 180 degree, and then from negative to positive parts, so dia akan change to phase lagi. So basically this is one kind of digital modulation. So you will learn this kind of digital modulation technique in chapter 3, where this is one kind of the phase shift keying technique. Comparison between PM and FM. So the modulation index. First is the difference in the modulation index. For modulation index for MF is frequency deviation divided by modulating frequency, or KFVM over FM. For modulation index PM is equal to KVM, or phase deviation. In PM, the modulation index MP is a function of the modulating amplitude VM only, and it is not function of the frequency. So for PM, they only depend on the modulating amplitude VM. Tapi in FM, they depend on VM and FM, sebab KFVM FM. But for phase, we only one component aja, iaitu amplitude. In PM, the phase deviation is proportional to the amplitude of the modulating signal VM. In FM, the frequency deviation, so delta F, is proportional to both the amplitude VM and frequency. So when the modulating frequency is changed, the PM modulation index will remain constant, whereas the FM modulation index will increase as modulating frequency reduce. So basically the phase modulation is just for your understanding, and it is not a part of your syllabus. So I want you to try this question also, then we will discuss in the tutorial. And see you again in another class. Assalamualaikum warahmatullahi wabarakatuh.